friends. So coming back, this is the second lecture from the series heat transfer. So in the last lecture, we have seen 10 pages and we have stopped at this problem. So it's a simple problem where the amount of heat required is asked. It required to raise the temperature of 300 gram aluminium from 25 degrees Celsius to 70 degrees Celsius. So as we know, the formula to calculate the amount of heat required is mc delta T. So we have the M, which is 300 gram. We have the change in temperature, which is 25 degrees Celsius to 70 degrees Celsius, which is 45 degrees Celsius, right? Oh, sorry. Correct. 45 degrees Celsius. So, okay, one important thing you can note here, the values of C is in joule per gram degree Celsius. It's not in joule per kg. Okay, it's joule per gram degree Celsius. So if at all it was in joule per kg, then we have to mention in our equation M is equals to 0.3 kg. So unit will be same. However, since it is in gram, so I am keeping the 300 value same as it is, then 0.896 into 45. We will solve it ourselves. We will use the calculator. So 300 into 0.896 into 45, which is 12,096 joule. Since we are considering all the units in joule, the results will be in joule. If at all we want to convert it to kilojoule, we can just consider it as roughly kilojoule. Just we have to divide by 1000, we will get the value in kilojoule. I think there is some typing error here. It should be 12.096 joule. Okay, if at all anyone can get similar answer, please let me know. Another equation, calculate the final temperature. Okay, here the equation has been changed. Instead of the heat amount of heat required, they are mentioning the final temperature, which is after heating. So we will write the equation once again. First we will write the equation, then we will continue. So what is the question? Calculate the final temperature when 100 gram of iron at 80 degrees Celsius. Okay, so let us say 1 gram or 100 gram of iron at 80 degrees Celsius is tossed into 53.5 gram of water at 25 degrees Celsius. So final temperature 100 gram of iron at 80 degrees Celsius is tossed into 53.5 gram of water at 25 degrees Celsius. What we will do is we will make an equation heat lost by iron equals to heat gained by water. As you know, uh, if we are putting a hot iron in the water, cold water, definitely the heat will transfer from iron to the water. So heat lost by iron is equals to heat gained by water, which is mc delta T of water is equals to, sorry, iron is equals to mc delta T of water. So let us go with it. So it is 100 gram. Again, we have the value in joule per gram degree Celsius. So I will maintain the 100 value into 0.452 into, okay, so 80 minus the final temperature is equals to 53.5 into 4.186 into uh, initial minus final, so it will be TF minus 25, because temperature will increase, that's why it is TF minus 25. TF minus 25. So we will multiply the values now. So friends, values, okay, so basically what I have done is, what we have to do is we have to cross multiply the values. As we know, we have to multiply 100 into 0.452 here, and then 53.5 into 4.186 over here. Then we can divide those two values, so we will get 4.955, and then we can rearrange like 4.955 into 25. This value we can send here, and TF we can send to the right hand side. So after dividing the values, the final values will be 203,887 divided by 5.955, because TF will come here, to become positive. So TF plus TF, 4.955 TF plus TF, we will get the value 5.955. So 203.887 is giving a value of 34.27. So in this way also questions might come. So this is called as exchange of heat. Previously equation was calculation of sensible heat, but here this is exchange of heat. Okay, now come to the next part, latent heat, which is associated with phase change of matter. Okay, phase change of matter. So we have solid. In the solid, only vibrations occurs of the molecules which are very close to each other, whereas in liquids, some rotation, vibration, and translation of molecular motion is observed, and they are having a good gap with each other. Whereas gas, mainly translation will happen, and they are very far. Since they are very far apart, hence mostly translation occurs in the gases. So this is the phases of matter: vibration, rotation, vibration, and translation. In gases, only translation. So now different names are given, like heat required for phase change. Melting occurs from solid to liquid. When it goes solid to liquid, it is melting. Liquid to vapor, it is vaporization. Directly solid to vapor is sublimation. Special condition, solid to vapor, like in some cases, ice directly, if it's if we observe some metals, not much ice, but there are some specific materials where with sublimation it can convert from solid to vapor. So heat required, and this is the heat released, like condensation, vapor to liquid. If it goes vapor to liquid, then it's condensation, and if it goes liquid to solid, it is fusion, like we say heat of fusion, latent heat of fusion. Then vapor to direct solid, deposition. It is very rare, but still it is there. So heat required and heat released. uh, there's also some other points like freezing, we can say, melting, condensation, evaporation. And there is one important point, phase diagram for water. Okay, phase diagram for water. So as we know, important to note that these values are at 1 atmospheric pressure. For different pressure, the values will be different. Whenever we say water boils at 100 degrees Celsius, basically it